In this video, we're going to talk about the worksheets in the labs, then the schematics, or should I say the pictorials that go along with day 14 or topic 14 in your core refrigeration course. Now, let's start off with the subcooling worksheets. Now remember, subcooling occurs in the last portion of the condenser. It's a measurement basically of how full the condenser is with refrigerant and how efficient the condenser is working. Subcooling takes your condensing temperature and then the difference between the liquid line temperature leaving the condenser. So if we take a look at the diagram we have in front of us here, okay, we're talking the condensing temperature, okay? So we have to, before we do anything on this, okay, we have to convert that pressure, which is my high side pressure, to a temperature. Now the easiest way to do this is to come over to my temperature pressure chart. It's actually one of the only ways to do it. So we have 390 psi. Our refrigerant is R410A. So I'm going to come over to my chart and I'm going to find 390 or as close as I can get under the 410A column. So this is my 410A column. My 391 is probably as close as I can get. And when I come over to the left, that's 115 degrees. So we know that that is roughly 115 degrees. Okay, so the difference, 115 minus 110, my subcooling is 5 degrees Fahrenheit. Now, every one of these worksheets also asks you for ambient temperature. Ambient temperature is the air coming into the condenser. So in this case, basically it's 95 degrees. Why do I care about ambient temperature? Because my condensing temperature, okay, which is this number there, should be about 30 to 35 degrees above ambient temperature. So if I have 115 minus 95, okay, we have 20 degrees. So it's a little bit on the low side there, but everything else checks out right, so I'm okay. And this will be a little bit higher in refrigeration. This is probably an air conditioning condenser based on the fact it's 410A. So if I go ahead and let's look at the next one. Okay, I now have 134A, okay, as a refrigerant. So I'm going to come over here to my temperature pressure chart. I'm going to find 134A, which is my light blue. Okay, my pressure I'm looking for is 135. So if I come down here, my pressure is 135. And come over to the left to find my temperature, it's 105. So we know this is 105 degrees. That's the temperature in the condenser where things are condensing. So if I take 90 degrees and subtract it from 105, I get 15. Okay, so my subcooling is 15 degrees. My ambient temperature is 75 degrees. Now, let's do our quick little check for reasonability. Okay, 105 minus 75, 30 degrees. Okay, I'm fine with that. My condensing temperature is about 30 degrees above the ambient temperature. I'm actually perfectly fine with that. So that's how those two charts work. So again, just be careful about your refrigeration chart. Make sure that you and I'm just going to clear off my annotations on that one. And I'm going to do the same here, just so I don't save something we don't want to save. Okay. Now, again, just be aware about the temperature pressure chart and the subcooling. Okay, this is something you do need to do. It is on state licensing exams. So let me close this window and let's go ahead and take a look at some of the schematics. So On this day, we have a couple schematics we have to worry about. I'm going to go ahead and help you with the first one. Okay, this is a motor schematic. We've dealt with this one before. Pull line 1, bring it out here to be your common. Okay, go ahead and tie in all your motors so you don't forget about that. Bottom motor is a PSC because we have a run cap. Okay, so I'm going to come down here and we will connect that to the start winding. Okay, run winding always gets direct power. We don't put any switching in the run winding. We'll power that start cap or the run cap from that same location. Okay, now when we have a start cap, this motor up here, the compressor is a CSCR. Okay, I'm going to go ahead and we have a potential relay here. 1, 2, and 5 is the dead giveaway on pin numbers. We'll bring power in there. Okay, this motor, the one with the 11 ohm winding, is your start winding because remember, start is always more than run. So we'll bring that in there. Okay, pin 2 goes to start winding. And run winding, as always, gets direct power. Okay, my shaded pole, which is my condenser fan, we can bring across. And then we'll bring power down from the thermostat or from line 1 to the thermostat. Okay, so that's this diagram here. Okay, pretty direct, straightforward. So let's take a look at lab 14A just to go through what it's looking for. Okay, lab 14A is just we did this again the other day, but this is a basic evaluation procedure for an air-cooled condenser. I do not want you to use the same piece of equipment you used for the last lab. You can actually move over onto one of the reach-in coolers that's in the shop. Okay, or find a different piece of equipment. Try to use one with a different refrigerant. You're going to take your readings. You're going to take some readings off the system. Okay, you're going to look at your ambient temperature difference. And then you have some questions here. 3 functions a condenser performs. Desuperheats, condenses, subcools. We've been through that from our lectures. Okay, what can be used with an air-cooled condenser fan to prevent the head pressure from being too low in mild weather? Fan cycling control, which is just a type of a high-pressure switch. Why must an air-cooled condenser be located where the air will not recirculate through it? Well, if you continue to recirculate that warm air, the exhaust of the condenser back through the intake of the condenser, sooner or later it's going to get too hot and it's going to trip the high-pressure control. What does compressor amperage do when the head pressure rises? Well, it should go up because the compressor is having to work harder because of the higher pressures. What would the symptoms of a condenser if 2 fan motors and 1 stopped working? Okay, again, your pressures would go up because you're not moving enough air. What's the purpose of the fins on a condenser? It's all about surface area. The more fins, I have more surface area for air to blow across and absorb the heat from the condenser. What material is typical refrigeration condensers made of? It's normally copper and steel for the fins, but you can also see aluminum these days. What are the system results of an air-cooled condenser operating with a head pressure that's too low? You're going to have low suction pressure. You're going to have possibly freezing of the evaporator, and you will not have proper heat rejection. The pressures will just be all wrong. Lab 14B, Okay, upon completion of this lab, you'll be able to determine the correct head pressure for a system under existing operating conditions for air-cooled condensers. Okay, this is all about the 30-degree difference between the ambient temperature, which is the air coming into the condenser, and the condensing point. We've just went over this. This is just, please follow this through. Um, and then take a look at the questions, because I think you've seen some of these before and you should not have any issue answering any of these. Okay, it's all from the lectures and it's all a recap of what you've already done in this course. Okay, lab 14C, temperature pressure readings to determine subcooling of the refrigerant in the condenser. Please, please, please use a different piece of equipment than you did for lab 14A and 14B. The whole purpose of that is that you start getting you start seeing all the different equipment capabilities that are in the shop. I want you to be using different refrigerants, different pressures, and getting your gauges on and off different systems, and looking at the wiring of the different systems. For the questions here, how is subcooling used in troubleshooting a refrigeration system? It tells you how much refrigerant is in the condenser and how efficient the condenser is running. If a technician doing preventative maintenance finds low subcooling, what's the technician going to do? I would probably go ahead and take the rest of the pressures, and I would also be looking at the cleanliness of that condenser. Look at airflow. How would a technician find the appropriate subcooling for a refrigeration system? Technical specifications from the manufacturer, or actually look inside if there's a cover on the piece of equipment. Take a look inside the cover. A lot of times it's there. What is the correct subcooling for the system that you're working on, and where did you find the information? Okay, this one can be a little bit of a problem in the shop. I'm going to tell you it's 30 to 35 degrees, and it's because we're letting you know this if you're on the trainers. If you're on an actual piece of equipment in the shop, we want you to make sure you actually, let's go to the manufacturer's website and see if we can find it. Okay, and that basically takes care of the topic 14 labs and subcooling diagrams. Hope that helps.